It's our 57th lesson, and I know this is long and drawn out, but we're trying to deal with this in great detail. The biblical flood of Marion Fox, the Oklahoma City School of Biblical Studies. We're going to look at, this doesn't relate directly to the flood, but we're going to look at solar shrinkage and evidence of that. And we'll deal with that question. And of course, this gets into a question of how old the Earth is and the sun is, because of the question is the sun shrinking? That's our first question. Is it shrinking in size? And if it is shrinking, what's the significance of that solar shrinkage? And if it's shrinking, how is it shrinking? And I believe there's historical data that proves the sun has been shrinking for at least 400 years, at least the last 400 years. The first reason to believe the sun has been shrinking is based on data derived from the Royal Greenwich Observatory in England. Here's out of Physics Today, which is it is a fairly high-powered physics journal. But it's certainly one that makes you stand up and listen a little bit, because it's not like just a rag that has no meaning. All right. And here's the quote: "At high noon on every clear day since 1750." So they've been doing this since 1750. Astronomers at the Royal Greenwich Observatory have been measuring the diameter of the sun. So they've been doing this since 1750. And so, second reason, and what you're going to see here is that they've shown it's been shrinking. Second reason to believe the sun has been shrinking is based on data that's derived from the extent and length of solar eclipses. So how long do eclipses last? Extent of them and the length of them. Old eclipse observations, according to Physics Today, can also shed light on solar shrinkage, because a larger sun in the past would shorten the time of an eclipse. Makes perfectly good sense. The sun is presently shrinking quite rapidly, rapid by the standards of time the solar system is supposed to have existed. Of course, greater than or approximately 4.5 or a little more than 4.5 billion years for the solar system. Now, and again, this same article says, by analyzing data from Greenwich in the period of 1836 to 1953, John A. Eddy and Aram A. Bornazian have found evidence the sun has been contracting about 0.1% per century. Now, percent, the word per means divide, and cent, of course, is 100. So divide by 100. So that's 1/10 of 1% is what that is, 0.1%. During that time, corresponding to a shrinkage of about 5 feet per hour in the size of the sun. Eddy and Bornazian checked every possible source of error they could find that astronomers said might have caused errors in the reading, and discounted the possibility of the shrinkage being mere reading errors. So they rejected that. And of course, remember, their article was published, so it was a refereed journal. And so again, this is something that has caused trouble. The evidence is so strong that they did publish the information. In addition, this data was checked with data from the Naval Observatory in Washington, D.C., where the same type measurements have been made since 1846. So the comparison, they got the same results. Eddy and Bornazian claimed the sun is shrinking by 2 seconds of arc per century. Now, when I first began to study trigonometry back in around 1960, 59 or 60, when I first began to study this, I learned that they divided a circle up into 360 degrees. And that probably came from a Mesopotamian sundial with 360 days in their year. And then they had a sexagesimal base number system, a base 60 number system. And so they divided up each of those degrees into a minute, 60 minutes. And then they subdivided each minute into a second, 60 seconds of arc. And so that's how we got the 60, 60, 60. And we get to 60 minutes and 60 seconds on our clocks as well. We still see that on our clocks, base 60 system. But this is 60 seconds of arc. That would be a second is the 1/60th of a degree of a minute, and a minute is 1/60th of a degree. So that's of an arc. So that's how you figure out what that was. Sophia, O'Keefe, Leash, and Endall concluded that their calculation of the shrinkage was only 0.5 arc seconds per century. So they get 0.5 seconds rather than 2 seconds, but it's still shrinking according to their calculations. All right, so there wasn't some disagreement about the quantity. The figure's difference only 25% as large as the figure of Eddy and Bornazzi, and it really does not change the order of magnitude of the dating of the sun and the earth. And if you take the slowest shrinkage, there shouldn't be, according to the star we have, the sun is a star, our sun is a star, and there shouldn't be any shrinkage. It should be expanding rather than shrinking in size, contracting. Data used by Sophia et al. Was from the years 1850 to 1937, but different range, but covered a lot of the same time. Dunham et al. Stated between 1715 and 1979, a decrease in the solar radius of 0.34 plus or minus 2 arc seconds was observed. Now these are different sources. We have different sources saying essentially the same thing, just differing as to the magnitude of it. Gillen discusses several studies which all conclude the sun is shrinking. Now, of course, this is all in the book, and the references, you can cite them and look them up for yourself. While the large, now this is a quote of Gillen, while the large one second per century secular decrease in radius tentatively suggested by Eddy and Bornazzi is not supported by other investigations, the preponderance of evidence still supports a negative secular trend over the last few centuries. So it's shrinking for the last few centuries. It should be emphasized that stellar evolution theory, that's their theory of how the universe came into existence, predicts a positive, and particularly for our solar system and our star, albeit indetectable small secular trend for the solar radius. In other words, it should have been expanding, not shrinking. Any detection of a negative secular trend of the solar radius on a timescale of centuries would be a fundamental astrophysical significance. It would be very significant. A negative secular trend lasting for solar thermal time scales would present a more serious problem for astrophysicists than the off-measured solar neutrino problem. Now, the solar neutrino problem is they don't have near enough neutrinos coming from it for it to explain what the heat that they're getting is coming strictly from nuclear fusion, which gives off neutrinos. They don't have enough of them. Gillen also states, since secular evolution theory predicts a positive secular solar radius change with increasing age, 3.3 times 10 to the minus 6 arc second per century, any negative secular change, minus 6, that's 10 to the minus 6 is 1 millionth of, or detectable large positive change is quite significant. So any negative secular change or any detectable large positive change, because this is not a big change, 10 to the minus 6, 1 part in a million. So it's quite significant. So even an increase in the size of it is significant. What do you say? Gillen further says, given the many problems with the data sets, one is not inexorably led to the conclusion that a negative secular solar trend, radius trend, has existed since AD 1700. But the predominance of current evidence indicates that such is likely to be the case. So he's saying that preponderance of evidence is that it's very likely to be the case. Right? In addition, what does this mean? If it has been expanding and been shrinking, then if we project it backwards in time, it would have been bigger in time. And if we project it backwards and use uniformitarian assumptions, that is continuous shrinkage for 11 million years, the orbits of Mercury and Venus would be inside the sun in 11 million years. So this would be the case. In fact, the Earth would too, would be burned up. The atheist cannot allow this rate of shrinkage to be extrapolated backwards in time, as he does so many other things, without giving up his claim to Earth for over 4 billion years old. Because in 11 million years, you can just project it backwards. You can just take your distance there and project it backwards in time. So they can't allow that. And again, they have to reject uniformitarian assumptions, which a whole lot of their stuff is based upon uniformitarian assumptions. If this process were extrapolated backwards, it would violate the worldview of the atheistic astronomer. His worldview is that the universe is billions of years old, 15 or so billion years old. The solar system is, the Earth is 4.5 billion, and the sun is older than that. And so, according to the atheistic worldview, and so that would contradict his whole system. At this point, the atheistic astronomer rejects the empirical evidence, the science, what he can measure, what has been measured, what has been observed by empirical means, and clings to his atheistic worldview instead. There must be an explanation for this. And we know the Earth is 4.5 billion years old, say. It's possible that the sun may be giving off energy as a result of contraction resulting from gravity. And we're going to look at this more carefully. This would occur because of the loss of gravitational potential energy as the surface of the sun contracted toward the center of the sun. Let me illustrate this. Suppose there's a hammer that's on top of your roof and it slides off the roof and hits you on the head. You feel the pain of the energy, the gravitational potential energy being converted into kinetic energy or motion of that hammer as it hits you on the head. And it hurts. May even do damage to your skull. So there's energy in something that gravity pulls down. We can see the energy as motion or movement. And this can be converted into heat even. And so that's something we need to remember. That's as something moves downward due to gravity, it has to gain energy. And so that energy could be converted into heat. Right? This be derived from the formula gravitational potential energy, GP is mgh, mass times the gravitational constant times the height of it, the change of height of the mass, how much it changed. A loss of potential energy, as it moved downward, it loses that energy, and that potential energy is converted to actual energy. And with the hammer falling off a house, it would be kinetic energy mostly, but there would be some heat generated, but require the energy to be radiated. If this energy was lost, it's converted then primarily to heat or some form of radiated energy from the sun. And for me, the light or some other kinetic energy, it could be kinetic energy on other particles, causing other particles. You can see this if something falls into, like a rock hits a puddle of mud and splashes the mud up. So it can transfer its energy into upward motion of other objects. So we'll see this occurring in the sun itself. This theory was rejected. They rejected this theory that the sun was giving off energy due to loss of kinetic energy, loss of potential energy converted to kinetic energy and into other forms of energy. Why? Because they demand the sun be much younger than the claims of several billion years. Just won't fit their view, their age of the Earth won't fit it. The sun was merely given energy by gravitational contraction. It should spin faster as it shrinks. Now that's a principle of physics, very simple principle. Well, we have the conservation of angular momentum by which an ice skater spins faster as he pulls his arms toward his body while spinning, increases the speed of his rotation, slows it down by putting his arms out. And so that's the change of that potential energy as it moves in and out as arms do. It's beautiful to watch them do it. I enjoy watching them, ice skaters do it. This is not a problem, however. It doesn't pose a problem if the sun is only a few thousand years old, but it would pose a problem if it's 4.5 billion years old or plus. And for that, for this reason, because of the background of this theory has been rejected by atheists, and the theory that the sun gives off energy by nuclear fusion has been accepted. So nuclear fusion is supposedly the process, but which just happened. We need to be aware that the theory that the sun gives off energy by nuclear fusion has several major problems, and there's at least one major problem here. The process of nuclear fusion gives off particles called neutrinos, and the quantity of neutrinos coming from the sun is much lower than that required for nuclear fusion to be the sole source of the energy. Okay. Grimmon states the sun is producing fewer neutrinos than standard theories predict, page 14. That's kind of an understatement. It's quite significantly less than they predict should occur. Some of these problems with neutrinos are discussed by Bacall et al. And Peterson, Rackhaven, and Taubes. These are the sites for them. You can look them up in the book yourself. Either one, the method of measuring neutrinos is inaccurate, that's possible, or something is stopping the neutrinos, and they don't know what that would be, or the theories of production of neutrinos is wrong, their theories of the nuclear physics is wrong, or some other process besides fusion is causing the sun to emit energy. It could be that it's a combination of gravitational contraction and fusion giving this. So it might be a combination of more than one process. Nuclear fusion can be started with a laser, for example. It just requires heat to accomplish the process of fusion. Perhaps part of the energy from the sun comes from gravitational contraction and part of it comes from nuclear fusion. I think it's entirely possible that the nuclear fusion started later, that it started by gravitational contraction and the fusion then started. And that changed things on the Earth at this time when that occurred. Gravitational contraction could generate enough heat to sustain the nuclear fusion. That's possible. We have 8 planets now. They've decided Pluto's not a planet. That's just by definition. But the 8 planets, 4 of them are what are called Jovian planets. The other 4 are terrestrial planets. And the 4 inner planets, Mercury, Venus, Earth, and Mars, are terrestrial or Earth-like planets. And the other 4 Jovian planets, they're like Jupiter. And so they're like Jupiter. Jupiter is a gaseous planet that's thought to have a solid core, but so the large gravity then has gases in a form. Probably much of it is even pretty well solid form. But they're gaseous planets. The inner part's more solid. And these planets, 3 of them, are known to radiate more energy than they receive from the sun. Now, our moon is a reflector of light, and not a source of light, by and large. And so it's pretty well not giving off any light, it's just reflecting light. But these 3 of the 4 Jovian planets are known to give off more lights than the light that they're reflecting. So they're not just reflectors, they're actually sources of light. Here's a quote. The existence of an internal energy source within Jupiter was discovered in 1969 when the first infrared flux measurements indicated that the planet radiated twice as much energy as it received from the sun. So basically, Jupiter is a star itself. Jupiter is a star that's radiating kind of weakly, not strong light. Later measurements from Earth and from space confirmed this result and established the presence of internal energy sources within Saturn and Neptune, but not within Uranus. Uranus is named after the word, Greek word for heaven, I believe. Incanes and so forth, that all tell us that. The fact that these planets are net energy sources is explained by these Incanes and others. The most plausible explanation given for the excess of internal energy in Jupiter is that it derives from gravitation. The cause is either gravitational collapse that occurs when the planet was formed or internal differentiation of light and heavy elements. By that, he means the heavier elements are sinking deeper into the planet, and the lighter ones are moving upward. So the heavier ones, as they move down, will give off more heat, they'll gain more energy. And so that's what he's saying, differentiation of. If the sun produces energy exclusively by nuclear fusion, there are at least 3 possible ways the sun could be shrinking. Let's assume they're right, it gives its energy strictly from nuclear fusion. These are the 3. First way it's shrinking is that it is converting the mass into energy by the process of nuclear fusion, or by some other unknown process, or a combination of both known and unknown processes. So nuclear fusion can convert mass into energy. And we have, of course, the famous equation from Albert Einstein's equation, E equals mc squared. E is energy, and m is mass, and c is the speed of light, which was assumed to be constant. In some parts of space, is not constant because of gravitational lenses in earlier studies. When a hydrogen isotope is just a different, has a different number of protons in the nucleus, or neutrons. Sorry, not protons, but neutrons in the nucleus. 1H2. A normal hydrogen has 1H1. This 1 at the subscript will be the number of protons, and the 2 up here is the number of neutrons in the or particles in the nucleus, total particles. That would be a neutron and proton combination. So this would have 1 proton and 1 neutron. That is 2 particles in the nucleus. And they thought it was a different element at first, but they finally figured out it wasn't. But they named it as deuterium. A duet has 2, so it has 2 particles in its nucleus by weight. And when that 1H2, or as an isotope of hydrogen, has a proton and a neutron in its nucleus, fuses with the 1H1. That's a normal hydrogen atom, 1 proton and no neutron, just 1 proton in the 1H1 atom. It yields 2H3, He3 now. It has, by this, it picks up 1 plus 1 is 2 protons, making it helium, and it has 1 proton and 1 neutron, so it has 3 particles in the nucleus. But this is a stable isotope of helium, 2H3, by the formula. And here's the formula for it. It becomes 2H3, but it also gives off energy, frequently gamma rays. But this is a high energy electromagnetic wave, very high energy level. So that's the process of nuclear fusion. But it takes heat to trigger it, then it gives off more energy than the heat that was triggering it. This converts part of the mass of the two hydrogen atoms into energy, but it also gives off neutrinos as well. We don't have them in the process here. Right? It's the same principle as the hydrogen bomb operates by nuclear fusion. A hydrogen bomb, my understanding, is that it has to have enough heat to trigger it. That heat usually is generated by a small atomic bomb to set it off, but they have to have the right isotopes of hydrogen there, so they will take these isotopes and generate it. The third isotope of hydrogen, called tritium, it has one neutron, one proton and in the nucleus, and it has two neutrons in the nucleus. So it has three particles in the nucleus, tritium. So but it was also named, and they thought it was another element, but it's just an isotope of hydrogen. But this is the same principle which the hydrogen bomb operates, nuclear fusion. According to Hartman, page 19, the sun has a luminosity of 3.9 times 10 to the 26th power. Now, what that means, joules per second. And what we have here, 1 joule per second is a watt. A joule per second is a watt of power. And so this 3.9 times 10 to the 26. You move this decimal place 26 places over to the right and put 25 zeros after it right here. And that will be the number. That's how many watts or joules per second it gives off, watts of power. A joule per second is a watt. From the formula, M equals E over C squared, and we've solved E equals mc squared for M algebraically. This amounts to the mass of, if we take the joules per second, and we take 3 times 10 to the 8th meters per second for the velocity of light, the speed of light, c squared, we square it, we get 4.33 times 10 to the 9th kilograms. Now, a kilogram is about 2.2 kilograms weighs, a kilogram weighs about 2.2 pounds, at sea level on the Earth. Kilogram is mass and weight is different than mass, but you can convert mass into weight with gravity, okay? So on the Earth, it's about 2.2 pounds per kilogram at the sea level, normal gravitational field at sea level. And so this is 4.33, and then move this decimal place 9 places to the right. So move here and then add 7 more zeros after it. That's kilograms per second. Multiply it times 2.2 and you get how many pounds per second. That's converted to light every second. Now the light would be infrared, visible, ultraviolet, and maybe even gamma rays, but primarily these forms of light. Gamma rays would be real dangerous for us to have coming at us. So most of the light of the sun is not gamma rays. It's infrared, visible, and ultraviolet light. Okay. This amounts to 1.367 times 10 to the 17th power. So move this decimal place 17 places to the right, and that's how many kilograms per year. And then multiply that times 2.2, and you'll have pounds per year are being converted to light, or 5.46 times 10 to the 26 kilograms, move that 26 places in 4 billion years. Assuming the Earth's 4 billion years old, that's how much mass it would have gotten rid of. Now, that's a fair amount of mass. The second way the sun could have been shrinking is that it ejects large numbers of particles from its surface because of both intense heat and explosions on the sun, what we call sunspots. So that heat boils these particles up, gives them enough kinetic energy that they fly out from the sun. These are called the solar wind. Some scientists claim the solar wind has not changed its value since the beginning of time. That's the claim that's made by some scientists. So we'll look at that, at the solar wind in just a minute. There's no evidence, and they're looking at the moon and the samples they brought back from the moon. No evidence in the lunar sample of any change in intensity and frequency of solar flares, the solar wind or galactic cosmic radiation as far back as we can look into the history of the moon. They assume the moon is about 4.5 billion years old. So they are assuming then, since they see no evidence of fluctuations in these things, they say the solar wind has not changed for 4.5 billion years, because they assume that the moon's 4.5 billion years old. That's their assumption, see. Based on the assumption of that age, they say we can project backwards that far. The lunar studies, Burgess goes on and says, may indicate that the Earth's ice ages were not triggered by changes in the sun as had been speculated. Why? Because the sunspot activity and the particles from the sun that would be generated by heat have been constant over what we measured, the time that we measured by the material we brought back from the moon. If that's true, then the ice ages that Earth has experienced have not been due to the sun cooling down. Couldn't be, because if it cooled down, it wouldn't give off so many particles in the solar wind. There would be as many particles coming from sunspots. So that would not be the case. You can see a decrease in it. Other scientists claim the solar wind has changed its value, and at the present value is considerably less than what it was several billion years ago. The ones that say it has changed value say that it's actually decreased. So in the past, it was greater than it is now. So that doesn't help the atheistic timeline at all. The problem for them, not my problem. By analogy with what we observe currently in young stars, we may assume that the sun, which they assume to be a young star, in the first stage of existence must have experienced intense magnetic activity. Equally, by comparison with the stellar winds observed in TRF phases, it is possible to estimate the intensity of the primordial solar wind as being 10 to the 8th times its current value. So here's something that is 10 to the 8th. Now, what's 10 to the 8th? 10 to the 6th is a million, so this is 100 million times more than what they're seeing right now. That's what they're claiming. They give the intensity of the solar wind, present intensity. The solar wind is by far the most intense flux of particles. At present, this flux is more than 10 to the 8th protons per centimeter squared, and that being negative would be per square centimeter. Now, 2.54 centimeters equal an inch, so it's a square centimeter per second is how that would be read. 10 to the 8th would be 100 million protons. Every second for every centimeter area. Now, a centimeter is about 2.54 centimeters equal an inch. So it's something like a quarter of an inch, somewhere thereabouts, about a fifth of an inch roughly. So square inch. So it's not a very big area, but 100 million protons every second hit it out in the space. And its velocity varies from 350 to 650 kilometers per second. That's kilometers per second. Now, that's more than enough speed to be form the escape velocity from the sun. Won't fall back into it. It conforms to energy of a kilo electron volt, that's a measure of energy, per nucleon. And so we won't go into how that's defined. We won't worry about that right now. Ankernes, Bibbering, and Blanc continue, and they say solar cosmic rays 1,000,000 times less intense. So solar cosmic rays, these are cosmic rays coming from other stars than the sun, have an energy that is 1,000 times greater. 1 mega electron volt, 1 million electron volts per nucleon. So a kilo electron volt is 1,000 electron volts. This is 1,000,000 electron volts per nucleon. Nucleon is a nuclear particle of nucleus of an atom. They penetrate a few tens of microns into the regolith. The regolith is the surface of the moon, and a micron would be a millionth of a meter. A few tens of microns into the regolith. These values are on the surface of the moon, which has been a mean distance, an average distance of about 149.6 million kilometers from the sun. Now, a kilometer is about 6/10 of a mile. So you can convert that to miles if you like, but it's about 6/10 of a mile. All right. So the mean distance of the moon from the sun is approximately the distance of the Earth from the sun, about 93 million miles approximately. For the purposes of calculation, I'm going to assume the most conservative value for the solar wind, that it has not changed since the beginning of the solar system. I won't take the view that it's changed drastically. We'll leave that to other calculations. But my figures will be conservative when I get through because of that. Assuming the sun is an isotropic radiator, that is, it radiates equally in all directions, which we have no reason to disbelieve that it is, with a radius of 149 kilometers. It's a big ball out there in space. It has a surface area, using the equation you learned back in junior high school. Area is 4 pi r squared of 2.79 times 10 to the 25th square centimeters. Now what this means is you take this decimal point here, move it 25 places to the right, add 23 zeros after the 9, and that's how many square centimeters you'd have. Okay. So remember, 2.54 centimeters is 1 inch. That's a good approximation. Okay. With each square centimeter receiving 10 to the 8th or 100 million protons per second, this makes a total of at least 2.79 times 10 to the 33rd. Again, what we're saying is move this decimal place 33 places to the right, and that's how many protons per second would be leaving the sun in all directions. How many total protons be leaving the sun? Protons, of course, have a rest mass of 1.673 times 10 to the minus 27 kilograms per proton. That means if we plug that in with the number of protons we have, the sun gives off 4,667,436 kilograms of mass every second with the solar wind alone. That's a bunch of mass, 4 million kilograms. And a kilogram is 1,000 grams. And remember, a kilogram at sea level weighs about 2.2 pounds, roughly. The solar wind removes, therefore, 1.472 times 10 to the 14th. With this decimal place 14 places to the right, add 11 zeros after it here. 11 zeros after it. That's how many kilograms per year. That's just what the solar wind removes. And the present mass of the sun is 1.99 times 10 to the 30th kilograms. So that's removing a fair portion of it every year. If the assumptions of Incarnez et al. Are page 54 above we quoted are correct, the sun would have lost 1.472 times 10 to the 22nd kilograms per year from the primordial solar wind. Now, if we go back and use the higher rate of solar wind that's given by others, it would have been much faster. But we won't do that here. In addition, the solar wind particles have a kinetic energy of 1 FMV squared, and each one of them, they would have when we do the figuring, kinetic energy 1/2 m the mass here. The velocity is 500 meters per second, 500,000 meters per second, or 500 kilometers per second. That would give us 2.09 times 10 to the minus 6 joules per proton. That's how much energy would be released. Now remember, energy, mass has to be converted into energy for it to be all from from nuclear fusion. So we can take this energy and convert it back into mass. Solving it for mass, then, E equals mc squared, we would have 2.32 times 10 to the minus third kilograms per proton of mass that would convert into energy. Accelerate the proton from the planet's heat. It takes that much of its mass just to accelerate each proton from the sun's heat. If we total this up, I know it's getting in the problem kind of boring. We have 2.79 times 10 to the 33rd protons per second leaving the sun. Means it requires 6.48 kilograms of mass to accelerate all the protons leaving the sun each second. Now, that's not a lot, I understand. We're adding small quantities in here. Now, each of these will contribute to the loss of mass. If it's from nuclear fusion, say that we get this much, not a significant change. The third possible way the sun could be shrinking is that the density of the sun could be increasing. And that's what they're claiming happens in the Jovian planets, the three of them that are giving off more energy than they're receiving from the sun, as the reflectors. This is thought to occur in some stars as well. However, it's not supposed to occur in the stars in the class and stage that the sun is in its present stage of development. It's not supposed to occur in the sun. Again, remember, they assumed all of the stars are given off energy by nuclear fusion. Of course, they don't have enough evidence for it because they don't have enough particles that are given off called neutrinos. Gillen states a negative secular trend lasting for solar thermal time scales would present a more serious problem for the astrophysicists and the oft-mentioned solar neutrino problem. Keep that in mind. Now, this is a repetition of how we repeated something we've already had here. But I would emphasize that for emphasis. This is a serious problem for the astrophysicists. Extensive shrinkage of the nature found by Eddy and Bornasian that we saw on page 17 can only be explained by the sun producing energy by a means other than nuclear fusion. Just can't do it. They don't have enough material there to shrink it. I theorize, this is my theory, it's a theory and I admit it, that the sun is shrinking by these three ways in addition to gravitational contraction. It's a combination of all of these. That's why they're not getting the solar neutrinos. That's my conclusion. I'm not a high-powered person with degrees from Caltech either. Sorry about that. The energy emitted by the sun probably is also a combination of gravitational contraction and nuclear fusion. That's what I'm claiming. That's most likely the case. The most reasonable explanation of these facts is that gravitational contraction causes enough heat to sustain some nuclear fusion. And that nuclear fusion probably has increased over time due to the gravitational contraction creating more heat. So I think that's probably what's happened. Again, it's all a theory, and my theory is just as good as theirs, and it conforms with the facts. If the early sun only produced energy by gravitational contraction, nuclear fusion began after the creation, the decay of radioactive isotopes in the Earth would increase because of production of solar neutrinos. That is, these radioactive isotopes are triggered and their decay can be triggered by neutrinos. So solar neutrinos could actually accelerate the decay of radioactive materials, make them look older than they really are. Now, this concludes our study of this. I realize this has all been fairly technical, but do you have any questions or comments before I stop recording?